Hi everyone, welcome back. So today we are going to continue with our lecture. So today it's gonna be about polymorphism. All right. So let's continue. But actually, polymorphism is one of the techniques in OOP. So we have learned in chapter 5 about inheritance, and today we're going to understand how polymorphism techniques using OOP. Okay, so let's continue. So, okay, let's recap what we have learned in the previous chapter, which is inheritance. Okay, because you have to understand inheritance in order for you to understand polymorphism, because these two techniques is very important in OOP and it's connected to each other. Okay, so let's recap about inheritance. Okay, inheritance is one of the most important feature in OOP, like I mentioned, and because it allows new classes to be written that extend an existing class. That means the existing class is the parents, and then the new class is the child classes. And then the new class inherits all of the data fields and methods of its parents. Okay, and then it's a relationship where a child object is a parent's object. For example, car is a vehicle. Okay, and then you have to use the extends keywords in order for the child class to inherit all the data fields and methods from the parents. Okay, but only in Java that use extends keyword. If you're using other programming language, for example Python, you don't have to use extends keywords. Okay, there's a different way of implementing the parent-child relationship. And then you also know about overriding. Okay, overriding or data hiding. Okay, that's what we have learned in inheritance. Okay, what is actually overriding and data hiding? It is actually when a child class contains the same method or data as its parents. Okay, we have learned before if the child contain the same method with the parents and with the same name. Okay, and then super keyword. Also, super keyword is used by child class to access a field or invoke a method in the parents class. And then final class cannot be extended and final method cannot be overridden. Okay, that is the recap of what we have learned in chapter 5, which is inheritance. Okay, now you will see what is the difference between inheritance, polymorphism, and abstraction in the view of a code. Alright, so let's see. So we have two classes here. Okay, we have public class undergrads and public class postgrad. Okay, so we want to know how we use inheritance, polymorphism, and abstraction techniques in these classes. So here we have public class student, and then we also have public class undergrads and public class postgrad. So if you notice here, public class undergrad extends students and public class postgrad also extends students. That means public class student here is the parents, okay, where it declare the data type of name, gender, birthday, and it have a method for get age. Okay, and then public class undergrad extends students. You have the data type of grades and then get the method get GPA. And then public class postgrad extend students have the data type of integer papers and integer get paper taken. Okay, this how you see the relationship. That means here one parents here have two child class, which is the undergrad class and the postgrad class. Both of these classes will have the access to student class, which is the method to get age. So the two important effects that stem from inheritance are polymorphisms and abstraction. Okay, you gotta understand inheritance, then it will be easy for you to understand polymorphism and abstraction. Okay, what is polymorphism? Polymorphism is where an object can take on many forms. Okay, and then abstraction, it allows the creation of the abstract classes. Okay. So now let's take a look at the overview of the polymorphism. Okay. So actually the term polymorphism is the combination of the word poly, okay, poly which means many or multiple, and morph which means shape or forms. Okay. So in OOP polymorphism, it refers to the ability of an object to have many forms, which is a direct result of inheritance. Okay, polymorphism, it's like it's showing that those classes, those objects can have many forms. Okay, and then it's also distinctive object respond distinctly to the same messages. Okay, and then polymorphism mainly requires the ability to different objects to have methods with the same name. Okay, one of multiple object, okay, can wait. Okay, so we have multiple objects, right? And then, but each object can have different methods, but they all can have the same name. That is what we learn in inheritance about overriding. Okay, but remember, they can have the same name, but they must have different parameters. And then now let's revisit again how we assign or declare object. Okay, so in here is the example. My class object equal to new my class bracket. Okay, the class name here is my class, and then obj here is the reference variable, and then new keywords are used for creating the operator, object creating operator. Okay, so when we create a new object, we have to use the new keywords. And then my class, my class, that means my class here is the constructor of the class. So actually when you write a code, okay, when you write a code, my class object, okay, my class object, okay, actually it stored, the variable is allocated in the memory. That means it save the information to the memory, okay, about the object. And then when you write object equal to new my class, okay, here is the reference to the new object is assigned to my class. Okay, that's how you see in the code. You write like that, but in the state of memory, okay, in the state of memory, which means behind the scene of the code, that's how it works. So when you have parents and child class. Okay, so you have to remember that when you create a child class, the child class will possess all the fields and methods of the parents class. Okay, because uh, the child class will inherit all fields and methods from the parents class. And the child class object can do whatever its parents can do. Alright, so whatever parent class do, the child class can also do the same thing. And then that is making the child object can be referenced using parent class reference. So this is the most fundamental use of polymorphism, because using a parent class reference to refer the child object is what allowing us to take advantage of the benefit of polymorphism. Okay, so the fundamental use of polymorphism you have to remember is parent class reference refer to child object. Okay, that's the main thing about polymorphism. So actually, how can parent class reference to the child object? Okay, let's take a look at this UML diagram. So in this UML diagram, shape is the parent class and rectangle and triangle is the child class. Okay, in these child classes, rectangle and triangle here, if you notice, it has methods, which is the get area. Okay, so the get area method in child classes provide the actual implementations. Okay, so it do the calculation of the area in child classes and provide that information to the parent class. So if you see in the parent class here, the superclass, okay, superclass is parent class. Okay, superclass defines the expected behavior, the public interface to of all subclasses, and the program at the public interface. So here superclass also calling the get area, which means the get area in child classes already did all the calculation, and then the superclass, the parent class, the shape class, only do the reference to the child object, which is the get area here. So basically this is just a detailed explanation on the example in the previous slides. So it says here, from the following class diagram, suppose that our program use many kind of shapes, okay, names as triangle and rectangle. Okay, and then parent class called the shape class, which defines the public interface or behavior of all the shapes. All right, and then parent class have a method called getArea, which cannot be computed unless the actual shape is known. Okay, so there are two child classes that are derived from shape, which are the triangle and the rectangle, and the child classes override the getArea method inherited from the superclass and provide the proper implementation for the getArea. So in the triangle class, it will compute the area for a triangle, and then in rectangle class, it will compute the area for rectangle. So example, if we have another child class which is circle class, and then the circle class will compute the area for the specific circle class. Okay, that's what it means by parent class reference to child object, right? And this is the example, the code example, how we can write to create the shape class, which is the parent class. All right, so you can see it defined the private member, which is the color, and then the constructor for this class, which is public shape, string color, and then it returns the color. Okay, this is the detail for the shape class. Okay, now let's move on to the another example of the child class. Okay, previously that's how the parent class, which is the shape class, was created, and this is the rectangle class. Okay, the child class that will extend the shape. All right, so you can see here in the one of the method, okay, the last method here, public double get area, and it return the length times width. Okay, it will return the specific area for rectangle. All right, so the superclass will get the value if it's trying to retrieve the area of a rectangle. And this one is the triangle class. Okay, the second child class. Okay, and if you go to the public double get area method, there you can see it returns the calculation how to calculate an area for a rectangle. If you notice, it's different calculation, right? So rectangle calculate the area of rectangle, and triangle calculate the area of rectangle. And this is the code for the main class, which is we are trying to print out the area for rectangle, and then the area and color, all the information for both rectangle and triangle. Okay, so you can see here in this main class where we get the area. Okay, if you see in system.out.println for shape 1. Okay, for shape 1, system.out.println area is s1.getArea. So since we already declared shape 1 as the new rectangle, it will redirect, specifically it will get the information from the get area method in the rectangle class. All right, and then for shape 2, we define it as a new object for a triangle. So system.out.println area is s2. It will get the area from the triangle class. Okay, so the output supposed to be, it will show you all the information for the rectangle and triangle new objects. So based on this example, it shows that the reference from the parent class to point to a child object. Okay, how did we do the reference process? Okay, shape 1 S1 equal to new rectangle. Okay, this is how the parents refer to the child object, okay, for both rectangle and then triangle. Okay, it says here the left side of the code creates the reference, okay, which is the S1 and S2, which is the type of the shape. And then the right side of the code is a new rectangle and a new triangle object. All right, so the is a relationship carries over to polymorphism. Okay, the relationship here is a relationship as we learned in the previous chapter. Okay, the relationship between parents and children is a relationship. And then rectangle and triangle object is a shape object. Okay, it's showing the rectangle and triangle, which is the child class, is an object, is a object for shape object, which is the parents. So in polymorphism, we can also invoke all methods defined in shape class for the reference of S1 and S2, which actually hold a rectangle and triangle object. For example, here, how we can invoke the parent class shapes method. Okay, if you see in shape class, we have method color. Okay, so how can we invocate the method color from the shape from the shapes method, the parents method? Okay, we can just simply do by writing s1 dot get color bracket s2 dot get color. Okay, this is because a child class instances possess all the properties of its parents class. It's called the upcasting. Okay, so all the data field, all the methods inherited by the child class. Other than that, we can also invoke all override methods, the get area and toString in a child, rectangle and triangle. So how can we do the process? So this is how you invoke the override method in child class. Okay, first you run the overridden version first. Okay, set s1.getArea, s2.getArea, and then you will run the rectangles toString, okay, by writing system.out.println s1 for the rectangle, and then you write system.out.println s2 to run the triangles toString. Okay, but it will invoke subclass, which means the overridden versions that will hide the parent class method. Okay, this is because S1 and S2 is in fact holding a shape object internally. However, you have to remember that you cannot invoke methods defined in rectangle and triangle class. For the reference of S1 and S2, you can only invoke it from the parent class. Alright, so example here, if you try to invoke method from the child class, it will give you the compilation error. So this is because S1 and S2 is a reference to the shape class. Alright, so it's within, internally in the shape class. So which does not know about methods defined in the child class, the rectangle and the triangle. So to access the child method from the parent reference, we have to cast the parent reference to the child reference first. Then after that you can invoke. You have to cast the child method from. You have to cast the parent's reference to the child reference first. Then you can invoke the method from the child class. So now let's revisit the casting reference. Okay, how we do casting reference in OOP. Okay, actually casting reference is the process of forcing a conversion from one type to another. It's called casting. Okay, the Java programming language has a special notations for cast. All right. So for example, we try to convert the type of expression O underscore X into double form. Which is the original type is string. Okay, we try to convert from string to double. Okay, so how we can do it? I'm pretty sure that all of you already know, because this you should already learn in your programming techniques course last semester. Okay, so how can you do it? You can do by writing string old underscore x equal to 3.405. Okay, this is the original. All right, the original expression. So we want to change it to double, right? So we write double new underscore x equal to bracket double old x. So if you want to do this casting process, if you want to refer the child class process in the parents class by the objects. For example, earlier we have object S1 and S2. You want to do the casting. This is how you have to do. Okay, then it will recognize the method that already defined in the child class. If not, you will get the compilation error. It will not work. And then we can also revert a parent class reference instance back to the subclass reference. So this is what we call downcasting. Earlier it was upcasting, and this one is the reverting a parent class reference to the subclass reference. We call it as downcasting. So for example here, for if we have method 1, okay, shape S1 equal to new rectangle rect 4 and 5. Okay, we define the for S1, and then rectangle rectangle as one. So this is how we do the downcast. The downcast need the casting operation. Okay, you have to do this way in order to revert the parent's class reference instances back to the subclass reference. So now you should understand how can we do the upcasting and downcasting when it involves the parents class and the child class. So here how we do the downcasting, okay, how we show we do the downcasting for rectangle, which is the shape 1 referring to the rectangle class, which is one of the child class. Okay, and then okay, so if you see in the second box here, shape, we define shape S1 equal to new rectangle, and then we downcast by referring it back to the rectangle, which is a new object rect, to rectangle, which is referred to the S1 which is the rectangle. Okay, and then when we use rect, okay, when we use rect dot get width, it will be successfully get the method from rectangle class. Or you can also write it as rectangle S1 dot get width. Okay, either way you can do rec dot get width, or you can do bracket rectangle S1 dot get width. Either way will work in order for you to get the get width using the method get width from the rectangle class. Okay, this is the UML diagram for the shape class, rectangle class, and triangle class. Okay, so how we do the process? If the child class want to refer to shape class, we call it as upcasting. If the parents class wants to refer to the object in the child class, we call it as downcasting. So when we use parents, okay, when we use upcasting, we refer to the parents, we call it as reference. Okay, when we do the downcasting to the child class, we use the object. Okay, as earlier we defined the S1 and the rect object in order to use the method from the specific method in the rectangle class earlier. So now let's learn about one of the Java operator. We call it as instance of. Okay, instance of operator. So we use this kind of operator to test whether the object is an instance of the specific class, such as class or subclass or interface. Okay, so this instance of operator, also known as type of the comparison operator, okay, because it compare the instance with type, so it will return to you either true or false. Okay, so when we apply instance of operator with any variable that doesn't have any value, which is null value, it will return false. Okay, so now let's see how can we use the instance of operator in your Java code. Okay, so we have here the public class animal, and then public class dog extends animal. So you immediately know that public class animal is the superclass, which is the parent class, and then public class dot extends animal is the subclass or the child class. Okay, so now we have another constructor, which is public class test instance of. Okay, so in this specific class, okay, we are trying to do the comparison. Okay, because the instance of operator, we use it as the comparison operator. Okay, it will compare between types, either true or false. Alright, so let's see. We have animal D equal to new dog. Okay, and then system outprint line D instance of animal. So it will check in the child class and the parents class if this is true or not. Okay, animal D equal to new dog, so that means it is true, which means D is the instance of the animal. Okay, and now let's take a look at the polymorphism code example. Okay, I'm just gonna go through it. It's about the Malaysia driving license system. Okay, let's go through it together. So here we have public class pemandu. Okay, we don't see any extends keyword here, so we can assume that public class pemandu, this is the parent class. Okay, here you can see we define the protected data types here: string name, IC, which is the identity card number, jantina, which is the gender, and then the class, the class of the driving license, either B or D. Okay, and then in this specific parent class, we have three methods here. Okay, we have get pemandu, get CC, and then we also have the white space. Okay, now let's take a look at the child classes. And this is the class B2. Okay, class B2 extend pemandu. Okay, this specific class B2 is for the type of class. Okay, for the type of class of, for example, B is for motorbike, no, B for cars, D for motorbike, something like that. So okay, and then let's move on to another class. Okay, here we have the class D. Okay, class D also the child class, it extends from the pemandu class, which is the parents class. Okay, this class is for car. Okay, it will define what is the if the how to say it, if the transport, okay, is not more than certain kilograms, so it will be a D class. If not, it probably will be in another class. Okay, so now this one is class B1. Okay, class B1, you can see here class B1 extends B2. All right, so that means class B1 is the parents for B2. So if you remember earlier, B2 extends pemandu, okay, in the previous two slides. Okay, that means here is the hierarchical here. So pemandu is the main parents, B2 is the child, and then B1 is the child to B2. So there's like three layers of relationship here. Okay, so in this specific B1 class, it also override the method from the parents, which is the get pemandu. Okay, when it override this method, it will get the information from the main parents, which is the pemandu, to get the name and to get the IC and then to get the gender of the particular person. Okay. And then another one, okay, another one we have class B full extends B2. So that means in this relationship, B2 have two child. Okay, B2 have two child, which is previously B1, and then this one is B4, also child to B2. Okay, so in this hierarchical here, there will be parent, there will be pemandu B1, and then below B, no, pemandu B2, and then below B2 is B1 on the left side, and then B4 on the right side. Okay, in this specific class, you will have two override method. Okay, one is to get CC, and then second one is to get all the information about the driver from the main parents, which is the pemandu class, the same as the previous class, which is the B1 class. So this will be the main class of the situation. Okay, in the main class we will define four instances here. Okay, we define pemandu P1 with as a new object for B2, and then pemandu P2 as the new object for B1, and pemandu P3 as the new object for B4, and pemandu P4 as the new object for the D class. And then we will get all the information, as you can see here, P1.get pemandu, all the information we will get from the main parents, which is the pemandu class, and then we will get CC, the white space, all of it from to its specified classes that we define. We define all those methods in those classes. So this is the example, okay? And this will be the output for the code that we went through earlier. Okay, it will print the specific name, okay, Johnny, and then it will also shows, okay, class B2, the motorcycle tidak melebihi 250cc, and then all this information dia dapat daripada mana? From those classes, okay. And then second one, Joya with the ID number, and then the gender is a female, and then B2 class and B1 class, and then a motorcycle not more than 500cc, and so on. So this is the overview of what is actually an abstraction. Okay, so when you try to implement the abstraction feature in OOP, it's actually you are trying to ignore irrelevant features, properties, or functions and emphasize on the relevant one. Okay, so maksudnya apa-apa features yang tak penting you trying to ignore. Okay, tapi you focus on the important one. Okay, and then an abstract class is incomplete in its definitions since the implementation of its abstract method is missing. Therefore, an abstract class cannot be instantiated. In other words, you cannot create instances from abstract class. Okay, normally we can create instance. Okay, for example, create new object. For example, we create new rectangle. Okay, new rectangle. That means we are creating an instance in a child class or in the main class or in the parent class. Okay, tapi in the abstract class, you cannot create instance. You cannot create an instance in the abstract class. Okay, so how can we use this abstract class? Okay, you have to derive a subclass from the abstract class. Okay, you can ambil the subclass, the child class, get it from the abstract class. So in the derived subclass, okay, in the derived subclass, that means the one that you derive from the abstract class, you have to override, okay? You have to override the abstract methods and provide implementations to all abstract methods, okay? You have to use the override keyword, okay? And then the subclass derived is now complete and can be instantiated. So that is how you can use the abstract class. So now let's see the differences between abstract class and the concrete class. Okay, what you are using right now, okay, is the concrete class where all the methods are completely implemented. Okay, that is the concrete class. So abstract class, okay, what is abstract class actually? It's a class where one or more methods are declared but not defined, meaning that compiler knows that the method is there, but part of the class is not it is there, which is it is part of the class, but it is not executable. Okay, it is not like it's not like overall not executable, but for the specific task, the compiler will not execute that specific method. Okay, this is called the abstract method. Okay, so actually we use abstract class to generalize the common behavior that otherwise be duplicated across subclasses. So actually it can save the memories. And then let's see the code example. Okay, here is the code example for based on our previous example, which is the driving license system. Okay, you can see here, this is the example of the abstract class. All right, so this abstract superclass pemandu contains an abstract method. Okay, if you notice in this abstract class pemandu, it have two methods, which is the getCC and the getPemandu, to be implemented by each subclass, or we know it as concrete class. Okay, so how do we implement it? So we write the abstract in the front of the class. So we put abstract public class, and then we add two modifier, which is we add abstract protected void get pemandu, and then abstract protected void get cc. That is how we can use the abstract classes in order to let the subclasses to implement the get cc and get pemandu here. All right, so that is all for the chapter 6, which is polymorphism. Okay, so there will be lab 6 coming up in order for you to understand more in the implementation of how we use polymorphism techniques in Java OOP. That's all for today. Thank you.